of the class. Yesterday I tried another trigonometric equation, and then I got different results from integration. I bought same result when I put same x.
Interesting. Let's do it in the tutorial. Is it juicy? Juicy?
Yeah.
Very juicy? No, it doesn't sound very juicy. It sounds like a boring question. But I'll do it in the tutorial, okay? Right. We are on the next lesson in maths, please. We are on the next page. I understand that might be confusing. Okay, continue. Is this a good question?
Oh, not really.
Go on.
You see, Java is boring, but I checked the module for University of Manchester, University of Sheffield, even NUI. They don't teach Java.
Because there's a basic.
I know, and I have to learn Java too on my computer
You
course.
don't get to choose.
No, still boring. Not on my computer course I'm doing, it's Java.
Java.
Okay. May I please? Thank you.
Why do I study Python then?
Because it's better.
Okay.
Right. Oh. Ready?
Yes? Go.
So, in this lesson, Sean, we will be proving trigonometric identities. In other words, proofs. So, let's do some examples. I shall do A. Prove 1 plus tan squared x equals sec squared x. Okay, let's check it. You have 3 ways you can do this question. 1 plus tan squared equals sec squared. 3 ways to do this question. The first way is you start at the left and try to reach the right. The second way, you start at the right and try to reach the left. And the third way is you start with both of them and try to reach something which is true. Which method will we use? It doesn't matter. I think I will use the method where we use both of them. So we can say this is 1 plus sine squared x over cos squared x equals 1 over cos squared x. Yeah? Multiply by cos squared. Which is obviously true. But that's an easy one to start with.
Well, you know what? Cycle where equal
Here. Here.
Right one.
Here.
Yes.
No, that's sec. Sorry, sec. Sec.
Teacher, do we have to mention which side proof to which side?
No. Not necessary. It'll be obvious. It's fine. Okay, another example. Can I scroll down?
Yeah.
Yep. Okay. Now let's do E. Actually, that's an interesting one. Prove tan pi over 2 minus x equals cotan x. Now, this one is definitely easier to start on the left, because what you can do is you can say tan pi over 2 minus x equals tan pi over 2 minus tan x over 1 minus tan pi over 2, plus tan x.
Oh, yeah.
Yeah. Now you might think, easy peasy, finished now, but not quite finished. So the next thing you need to do is divide everything by tan pi over 2. So this is 1 minus tan x over tan pi over 2 over 1 over tan pi over 2 minus tan x. Now what is 1 over tan? That's cotan. Yeah, so what I'll do is I'll change this into 1 minus cotan pi over 2 tan x over cotan pi over 2 minus tan x. Now, what is cotan pi over 2? Have a think. Tell me what you get.
No.
No. Cotan pi over 2.
1.
No.
0.
Minus
Yes.
0.
0. Because cotan
Oh.
is cos over sine,
Yeah.
and cos pi over 2 is 0, and sine pi over 2 is 1. So cotan is 0. Cotan is 0 here and here. So if these are 0, now I keep changing that into a minus sign, that's a plus. If these are zeros, then you're left with 1 over tan x, which is cotan x. We getting the idea?
Not really.
Okay, well, let's just look at some together. Can you all look, please, at question F? Have a look at question, have a look at question F there. What would you do in question F? Which side would you start on?
Right to the left.
Start on the right and get to the left. Question I, what would you do?
Right to the left.
Right to left, yeah.
Oh.
Or both together, maybe, yeah, that's fine too. What about question N?
Right to the left.
Right to the left. Now, get a bit harder. What about question Q?
Right to the
Left to the right.
No. I think it might be easiest to do both together.
How can we do both together? I mean, we can just make it equal to 0. If we
No, like here's an example. Here, Lee, this is me doing both together. I took as my starting line the full equation and reduced it to an equation which is obviously true.
Oh, so we have to, I mean, the formula has to be like this.
In other words, you have to simplify to a formula which exists or which is obviously true. Because if you start from the left, it's not clear how to get to the right. And if you start from the right, it's not clear how to get to the left.
Let's see.
Yeah? What's wrong, Sean? No, go on, what's wrong? Look, I'll do Q now. I can.
Let's go right to the left.
Shh, I'll do Q now. Can you read out Q to me there, KJ? What do I have? Sine 2x, is it?
Two tangent x.
Sine 2x is 2 tangent x?
Over 1 tangent x. Okay.
Like this?
Yes.
Okay, let's try this. I think... What? Okay. I'm going to start with both.
Okay.
So I have 2
Sin x, cos x.
2 sin x cos x equals 2 sin x over cos x over 1 plus sine squared x over cos squared x. Okay. I suppose I can cancel 2 and 2, sine and sine, and I can bring the cos squared up. So now I have cos squared x equals 1 over 1 plus sine squared x over cos squared x, which is cos squared x equals 1 over cos squared x plus sine squared x, because this is over 1, so I can add them together. Now what can I do with this cos squared? I can take it up here, so now I get cos squared x equals cos squared x over cos squared x plus sine squared x. What's cos squared plus sine squared?
1.
1. So you end up with cos squared x equals cos squared x, which is obviously true. What was your idea, Monica? No?
Why don't you cancel out the cos squared x?
Yeah, I could. Doesn't matter. If I cancel out the cos squared x, at the end I'll just end up with 1 equals 1 over cos squared plus sine squared. So I'll end up with 1 equals cos squared plus sine squared.
X equals 1 minus sine squared x. What I was thinking is true.
But it's not. But there is a better way to do this. Can I continue? So here is question Q again. But this time I'll start from the right. So what would I have on the top? 2 tan x over 1 plus
tan x squared.
Yeah, this equals 2 tan x over sec squared x. And the reason for this is from part A. Because in part A you showed that 1 plus tan squared x equals sec squared x. True?
Yeah.
So this is equal to 2 tan x, which is 2 sin x over cos x over 1 over cos squared x. Cancel equals 2 sin x over cos x, because what I can do is multiply this by cos x and multiply
No.
Oh no, so what am I doing? Sorry. I can take this up here.
Over 1 over, yes.
Over 1 over cosine.
Hang on, I'm getting confused.
Over
Two-
1 over sin
2 sin x cos x, what am I saying? So
Yes,
sorry,
sin
which is
x.
sin
Right.
2x, because I can take this up here. Yeah, or yeah, what I was saying, multiply by cos x
Yeah.
also works. Yeah. So, for this exercise, you can use the basic rules like, you know, cos squared plus sine squared equals 1, or, you know, sine A plus B, or whatever.
Yeah.
But also, you're allowed to use anything you proved earlier. So if you proved something earlier that's useful, you can use that result. Like here, I used the result from part A to help me in part Q.
Well, teacher, during the exam.
No, of course, obviously you can't do this during the exam.
Yeah.
But in the exam, either two things will happen. They'll ask you to prove something and then prove something else, or they'll ask you to prove something that requires just a basic rule. We have the idea with this. It's not too bad. Can you try these for a few minutes, please?
Is it possible they ask us to prove something that cannot be proved?
Your question is it possible they'll ask you to do something that is impossible? The answer is yes. Only,
Yeah.
well, if you didn't want the answer, why did you ask me the question? Your question is, could they ask you to do something that's impossible?
Yeah.
Yes, only because they made a mistake.
That makes sense.
And in that case, you will get the marks anyways. But if you're sitting in the exam and thinking this is impossible and they're asking me to do it, that could happen. Now, that I cannot think of any example recently, at least, where that has happened. So you're probably safe.